students, our topic is push-down automata. It is a combination of finite automata and stack, where stack is used to store what it reads. Suppose we have a language L is equals to a ki power n, b ki power n, where n is greater than equals to 0. If we put n equals to 1, then we get the language a, b. If we put n equals to 2, then we get the language a and bb. As finite automata does not have memory, which can compare whether this number of a is equals to number of b or not. In PDA, that is push down automata, we have stack for this facility of memory. As in PDA, we have an input tape. Input tape consists of the different inputs from A1 up to AN. There is a finite control which perform all the operations. It reads the input from the input tape and also reads from the top of the stack. This is a stack which is used for the memory purpose. Now let us take an example of construct a PDA for language L equals to a ki power n, b ki power n, where n is greater than equals to 1. Here, because n is greater than equals to 1, we put n is equals to 2. For n equals to 2, language is equals to AABB. For n equals to 3, language is equals to AABBB, and so on. Now, to solve this, firstly we take a stack from the bottom Z0. Z0 represents the bottom element. If we encountered the same string, then we simply push the element into the stack. If we encounter the different, then we simply pop the top of the stack. For example, for the string AABB, firstly we encounter A, then we simply put that A into this stack, that is A. Next we encountered A, then we simply put this element into the stack. Then when we encountered B, we delete the top of the stack of the element, that is A, and for another B we pop the element, that is this A. If we get after the deletion Z0 as the bottom element, then it is to be find that number of A is equals to number of B. Now, starting from the Q0 initial state, for the current input A and the top of the stack is on Z0 and the string to be inserted is A Z0, and we reach to the state Q1. And when we have same A as another input, it remains on the same state, that is Q1, with the input as A, top of the stack is on A, and the string to be inserted is A. After that, when we encountered B, we simply insert that element B with the top of the stack is A, and we do not insert any string that will represent with empty, okay, and it goes to the states Q0. If we have, then further we have that B which remains to the same state Q2 with input B having top of the stack at A, and there is no string to be inserted. At last we get the empty, that is this, with the input empty, and the stack is on Z0 without any string to be inserted, that is Z0. This is the required PDA. The main thing to be understand is that this transition function, which contains firstly the current input, that is this, the top of the stack, where is the top of the stack at the information state, and this represents the string to be inserted with every transition from one state to another state.